Based on the definitions of ensemble average or time average or local average, I will define three important types of turbulent flows, which are stationary turbulent flows, homogeneous turbulent flows, and isotropic turbulent flows. Let's start from the first one, which is the stationary flow. We define that if the ensemble average of the velocity, for example, in x direction at point A1 remains constant at all times, so I omitted the dependence of this velocity to time inside the ensemble. So because it's not a function of time, so we say that this turbulent flow is steady on average or stationary. So the flow, the fluctuations over time can be omitted, or in other words, you can compute the ensemble average at any arbitrary time, instance of time. So the flow average is steady, or the flow is steady on average. We have a very well-known hypothesis here, which is the ergodic hypothesis, which talks about the ergodicity of the turbulent flows. Ergodicity is a very important concept coming from the statistical mechanics. Maybe I've recorded some other videos about the definition of ergodicity in continuum mechanics, but let's you can Google it and find more text about this hypothesis in turbulent flows. So, from mathematical viewpoint, the ensemble average of the x velocity at point A1 at time t1 equals the ensemble average at point A1 at time t2. So, the difference leads to ensemble average is the time of performing the average. And the x velocity again at point A1 at time tn equals the other ones. This expression results that the ensemble average, you can omit the dependence on t inside the ensemble. So the ensemble of the x velocity, for example, at point A1 equals the time average of the x velocity at point A1. I have defined both the ensemble average, but this symbol here, and the bar velocity, or which shows the time average of the velocity field. So these are equal in stationary flows. Generally speaking, where the ensemble average of I component of velocity at point x1 at time t1 times the j component of velocity at point x2 time t2 and mth component of velocity at point xn time tn, ensemble average of this product equals the, again, copy and paste this relation here, but at a time interval t here in this parenthesis. So you see the ith component of velocity again at point x1, but at time t1 plus t, tn plus t. This is a kind of time translation. This means that the ensemble average is invariant or insensitive to the time translation. This is the definition of the stationary turbulent